Hi, we're in the second part of just trying to find slope. We're in a three-part series where I'm trying to find slope through a variety of means. Last video, we went through how to find it through a table, where we noticed this constant change for x and y. We noticed it in the table because we noticed that each time that x changes, it's changed by the same amount. This could have been +2, it could have been -5, it could have been +7, but just as long as it's consistent and constant, then it's what we call a linear equation. A linear equation has a line, and because of that, has to have the same increase as well as the same decrease each time, depending on if there is an increase or decrease. Well, because of that, we showed an example of what's not a linear equation through the example of this table. You can see that this table here, if I draw it graphically, doesn't really make sense because as I try to graph the line, there is these particular dots right here and right here that didn't really go well with the linear equation. Because of that, we're going to actually shift to how we do find slope using what we call a graph. So let me just propose this as an example. We're going to have two dots here. So I'm going to draw my linear equation here. I'm going to draw it at this point, which is the point -3, -1. And we're going to have this point up here, which is going to be 1, 3 this time. To change it, we're actually going to do 1, 2 to really help us get along with this. In customary fashion, what I'm going to do is that I'm going to try to draw the best I can for this linear equation. Alright, so we have this line right here. We have this line to go from this point, this -3 to -1, to the point 1, 2. In order for us to get there, there's a few things though. The biggest thing is that, well, how do we go from this point to the next? Well, using these two dots, we can ask ourselves, well, how can we, right? Like this is like kind of going and using Google Maps or our maps in general. How do we go from point A to point B? In our example here, what we can do is that we can see that we can maybe go up, we can maybe go down, we can maybe go left, we can maybe go right. Regardless of these four directions, we have to ask ourselves, what makes sense as I'm trying to go from 1 to? So I'm going to take this left dot right here, this -3 and -1, and I ask myself, okay, can I go left? Can I go right? Can I go up? Can I go down? Whichever way that I can get closer to 1, 2. I think the first part is that maybe I can go up. So I'm going to go up. I'm going to count how many times I go up. 1, 2, 3. And then I stopped, right? Because if I kept on going up like here, then it would take a lot more steps for me to do that. I don't really want to do more steps. So what I want to do instead is that I want to be able to just say that this is going to go up 3. So now that it's going to go up 3, I'm going to ask myself, well, since I'm at this arrow and where it's pointing at, I want to now go to the left or to the right. So I'm going to look here and I can say, oh, I'm going to go to the right. I'm going to count how many times I went to the right, and it seems that I went to the right 4. But how does this help me? What is the point in doing this as my slope? Well, let's remember that slope is going to be rise over run. So because it's rise over run, it's a change in y over the change in x. My change in y is, notice that it's along the grid, that the vertical line, the vertical line is my y-axis, while the thing that's going from left to right is my x-axis. So when I really think about the y, the change in y is really asking us, how much am I going up and down? So the change in y is, how much am I changing up or down? So you can see here that the change in y is going to go up or down. But then what about the change in x? Surely that has also a change. And yeah, since we had two directions, up and down, it makes sense that we're also going to have a change in x. This time not going just up and down, but it's going to go left to right. So the change in x is really much saying how much am I changing left or right. So right or left. So we have now how much am I changing up and down, up or down, and then change in x, how much am I changing right to left. So let's find the slope then. My slope always begins with the letter m, and I have a fraction. So since the change in y is really asking how much am I changing up or down, I have to look at what I did for my arrow. I went up 3, so I can do 3. And since it's up, it's positive. You can see that I'm going up to the positive direction. Well, let's look. I went to the right 4, and you can see I went from negative to positive. So chances are it makes sense that I'm going to do plus 4 as my answer. So my slope is 3 over 4. Let me show you another example, one that maybe does a similar thing, but to the point where it might have a negative slope. So 1, 2, 3, 4, 5. 5, 5, and lastly 5. So I just drew maybe a grid that has 5 up, 5 down, 5 left, 5 right, labeled as x and y. And what I'm going to do this time is that I'm going to graph like this. I'm going to graph here at negative 3, comma 1. And then after I have negative 3, comma 1, let's say we plot it here at this time. We're going to do 1, negative 4. And just like that, what we're going to do is that we're going to draw our line from there to there. So what I'm going to do is I'm going to draw a straight line from this point to this point. And then with the power of the tablet, it luckily says that that's a straight line. Okay, so we have this, again, dilemma where how do I do this? How do I notice the change from one point to another? Well, for one thing, you can just choose one point that you can go to another. Notice that I probably chose the one on the left, but it doesn't matter. Regardless of whatever point I'm choosing, we can still choose one from one point to another and just ask ourselves, how much is it changing by? So I'm going to choose maybe this bottom dot right here. So I'm going to choose this to begin with, 1, negative 4. Because of that, I'm going to ask myself, well, can I go left? Can I go up? Can I go down? Can I go to the right? I always ask myself first, am I going to go up or down? Well, since the second dot is going to be right here, it makes sense that I'm going to go up. So I'm going to draw an up arrow and count how many times I go up. So I'm going to go up 1, 2, 3, 4, 5. So I'm going to write that down. I'm going to go up 5. Now I'm going to ask myself, well, am I going to go right or left? Doesn't make sense that I'm going to go to the right, because if I go to the right, nowhere is it going to lead me to the right place. Because of that, I'm going to go to the left instead. I'm going to count how many times I go to the left. 1, 2, 3, 4. Because of that, I go to the left 4. Up 5, left 4. Because of this, let's say that I do that as a slope, right? Slope is going to be for m. It's going to be rise over run. But more importantly, it's the change in y over the change in x. Change in x. Change in y, change in x. Change in y means how much am I going up or down. Because I'm going up, I notice that I'm going from a negative to a positive. So now I know that up means that's going to be positive. I'm going to put that on the top. Plus 5. Now I look at the change in x. Well, this time it's a little bit different, right? Because if I see here, my x value, the first number, is at 1. But then my second value is negative 3. I'm going from a positive number to a negative number. So it's not positive anymore. It's going to be negative. So I'm going to put negative 4. Which means that when I mention the word left, it means negative. So I think that generalizes to these 4 directions. If I say going up or going right, that's going to be both positive. Remember that this is for y and this is for x. Meanwhile, if I say if it goes down or goes to the left, again, with x being left, y being down, both are negative. I think these sense of directions really helps. So that's how we find slope using a graph. By drawing an arrow from 2 points on the graph, it doesn't matter whatever points you choose. It could have been any of them. But as long as you draw the direction, whether I go up, down, left, or right, you can then use the slope for that.